Let us start this lesson by coloring this first table light blue, just for us to mark the area that we are currently working on. This table over here gives us the number of chemical engineers and mechanical engineers that Vedina Corporation deployed in various cities all over the world. For instance, this row tells us that there are 5 chemical engineers and 8 mechanical engineers assigned in Berlin. Over here, we can see that there are 6 chemical engineers and 8 mechanical engineers assigned in Canberra. And this list goes all the way down to our last entry in Seoul. Now we have here an empty column that's supposed to give us a total number of engineers assigned in every city. We can fill this table by manually doing the addition by ourselves, but also we can program Google Sheets to give us these sums by itself. For example, we can type in the following code in cell E4. The plus sign in between C4 and D4 implies that the values inside of these cells are to be added to each other. When we type in spreadsheet codes, we always start with an equal sign. Pressing the Enter key, Google Sheets gives us 13 engineers in total for Berlin. Occasionally, Google Sheets would suggest for it to do autofill on the cells that follow the one that was previously coded. If we click the check mark over here or press Ctrl and Enter, we see that Google Sheets automatically applied the same code on the cells below. If Google Sheets would not offer autofill, we can alternatively do this by selecting the coded cell, click and hold onto the bottom right square of the selection, then drag and release the selection all the way down. Now let's work on the second table. Let's fill this one with light orange to mark it. Now, this table shows us how many different kinds of flowers are present in each of the parks listed below. The different kinds of flowers listed for each entry are daisies, jasmines, roses, and tulips. Again, we have a column where the total number of flowers for each park must be listed. Unlike in the previous table where only 2 entries must be added, here we need 4 cells to give us a total. And we can get this sum in 2 different ways. Our first option is to type this code, where we perform addition multiple times in just one cell to get the sum. And again, we do autofill by clicking the check mark or by dragging the bottom right square downwards. Alternatively, we can use the sum function. This code gives us the sum of all cells between C14 and F14. If we need to add multiple cells that are arranged in a row, column, or block, I suggest the use of the sum function instead. Now, for this next table, let's fill it with light green. Just in case you're wondering, filling these cells with color isn't important in making the formulas work. We simply do this in this exercise so that we can easily find the tables and cells that we are currently working on. The commands and functions that we use in this example also work without cell color. Now, this light green table shows 5 customers of the Reyes Bakery. These 5 customers ordered cakes of different prices in which they had to give a down payment before being delivered. Our task now for this blank column over here is to automate the computation of the remaining balance or the amount they need to pay to complete their orders. For Andrea over here, who made a down payment of 720 Philippine pesos for a 1,060 peso cake, the remaining amount she needs to pay can be solved by subtracting the paid amount of 720 from 1,060. To do this computation on Google Sheets, we type in this code in cell E21. Then we can use autofill in order to complete the table. In this next table, which we shall fill with light blue, we are given the amount of fruits that was delivered to Rosanna Mart at the start of their work week. The sales for each fruit were recorded on Monday and Tuesday. We can see here that the Wednesday column hasn't been filled yet, probably because the Wednesday sales are still ongoing and are still being tallied. Nonetheless, we shall include the Wednesday cells in the calculation of the remaining stock here in this column. To calculate the remaining amount of fruits, we type in this code in cell G30. In this code, we see that successive subtractions from the original amount were done. Even though there are no data yet for the Wednesday sales, including them in the formula will enable our spreadsheet to update the remaining stock values. If we update the Wednesday sales, the remaining amount of fruits will also be automatically updated. Okay, now for this next table, which we shall fill with light orange, we are given the items that a particular customer has bought from the NRFM grocery. We see here the items and their unit prices in US dollars. Now, when we say unit price, this is the cost of one piece of the said item. The quantity column here, on the other hand, tells us how many of each item was bought by the customer. And over here at the right side, the cost column, which we need to fill up, tells us how much do all of one certain item that was bought is worth. For example, we see here that the customer bought 2 bottles of EG ketchup, with each bottle worth $1.53. The cost column cell for EG ketchup must give us how much those 2 bottles are worth, which is $1.53 times 2. To solve this with a spreadsheet code, we need to type this in cell E38, with an asterisk being used as the multiplication symbol. Then we do the usual autofill. Okay, now since this table shows the cost of each item, it might be worth adding a cell that shows the total bill of the customer. So let's format it this way, with these borders and the same color. And we type in a sum formula for the total cost of all the items, which must be shown in the customer's bill. This next table, which we shall fill with light green, shows us the results of a biology study or experiment where several dog breeds were made to run these distances, and their running times were recorded as follows. Now, the speed of an object is calculated by dividing the distance it travels by the running time. So, to calculate their speeds, we type in this code in cell E48. The slash in the code is used as a division symbol. Before we proceed to the next table, let's have a recap of how exponents work. When we see an expression like this, the 2 over here is called the base. The small 5 here in the upper right portion is what we call the exponent or power of the base. This notation is read as 2 to the 5th power or simply 2 to the 5th. To evaluate this expression, we must multiply the base 2 by itself 5 times, which is our exponent. This gives us 32. Let's have a couple more examples. 3 to the 5th power means we have to multiply 3 by itself 5 times, giving us 243. Negative 5 to the 4th power means we have to multiply negative 5 by itself 4 times, giving us 625. 7 raised to the 2nd power, also known as 7 squared, means we have to multiply 7 by itself, giving us 49. And negative 2.1 raised to the 3rd power, also known as negative 2.1 cubed, is evaluated in this manner, giving us negative 9.261. An important application of exponentiation is the calculation of the area of square regions. For squares with a side length of s, we calculate its area or the amount of flat space that it occupies as s squared. So, if the length of this square's side is 5.3 inches, we can calculate its area as 5.3 squared or 28.09 square inches. Now back to our spreadsheet. In this table, which we no longer need to fill with color, lists down several locations with rooms with a square interior. The width or the side length of these rooms are shown in this column over here. To solve for the area, we type in this code in cell E56. With the caret being used to indicate that the number at the right is an exponent to the number at the left. And we finish this exercise with one last autofill.